Let's look at another example of where we have to verify a trig identity. Okay, so we have this situation here, and again, you have to look at either the left side or right side. It seems like this one looks a little bit easier to work with, and the thing I'm kind of keying in on is I have this difference here, and it looks like I can factor out a sine to the fourth of x. Now that's a good thing because over here is a sine to the fourth of x, so we do need that. So we have a cosine cubed of x sine to the fourth of x equals, and if I factor out a sine to the fourth of x, we end up with 1 minus the sine squared of x times the cosine of x. Alright, now again, the nice thing about this is this part here looks like one of our Pythagorean identities. And let's see, we would have the sine squared of x plus the cosine squared of x equals 1. And I think I'm just going to substitute that in for 1. So we have the cosine cubed of x times the sine to the fourth of x equals the sine to the fourth of x. And then let's see here, we're going to have the sine squared of x plus the cosine squared of x minus the sine squared of x. And then this is all being multiplied by the cosine of x. Well, let's see here, the sine squares of x cancel out, which is good. And so we have a cosine cubed of x sine to the fourth of x equals a sine to the fourth of x times the cosine squared of x times the cosine of x. Alright, well, cosine squared times cosine is cosine cubed, so we have the cosine cubed of x times the sine to the fourth of x equals the sine to the fourth of x times the cosine cubed of x. And we do want them to look exactly the same, so the way we do that is just a little inverse, commutative property. So cosine cubed of x sine of fourth of x equals the cosine cubed of x sine fourth of x. And there you